Okay, we'll continue to see some more examples on overriding today also. We'll see again with simple examples which will help you to understand bigger programs. Okay, so let's start off now. See, I'm having one class A. Okay, this is the class A. Just a second. So in this class A, I'll have one method void m1 SOP inside AM1, and there is one more method I'll have void fun. So SOP inside AFun. Okay, there is one class like this now. Now the thing is, I want to inherit, means I want m1 but I don't want fun. Requirement is this. Okay, my requirement is, I'll create requirements and then start extending the classes. I want the method of m1 present in A, but I'm not interested in the fun method of class A. So what should I do? Instead of writing a new class, I'll inherit A, means I'll get both the functionality. Which functionality I don't want, I'll start changing. When I inherit, what will happen now? I'll get all the features. So that's what I'll do now. So my requirement is what? Actually, I do not want the logic of fun method. Okay, if I do not want the logic of fun method, what should I do now? Write one new class. One option is, first option is change here itself. Second option is, first option not recommended. Why? Oops says do not modify the code in any class. Other option is write a new class, write old method plus new logic. Not recommended again. So the last option comes to inheritance only. Which is the best? Among the three options available, inheritance will give you the best solution. So we say now class B extends A. So in extend, what will happen? I'll get both the functionality. Okay, if you want to use both the functionality and add new functionality, or you can change functionality also, that's up to you now. So what I'll do now is I'll add one new functionality called M2 SOP inside B M2. This is also fine. Okay, now but I'm not interested in the logic of fun. So what will I do? See, I added a new logic, completely new logic. Then I'm changing the logic present in A class. So we are inheriting and changing the logic, overriding it. So SOP inside B fun. So this is the story. Let's see how to work with these two classes now. See, today the title is method overriding. We'll see. At the same time, we'll see a new topic called as dynamic polymorphism. This is a very important topic now. Dynamic polymorphism. Java achieves very high level of abstraction because of dynamic polymorphism. Okay. Java achieves very high level of abstraction because of dynamic polymorphism. Anyway, that statement is complicated now. It's going to be easy in the coming classes. Let's see. Okay, but the advantage of see, what is the advantage of method overriding? With the help of method overriding, if you do method overriding, you can achieve what? Dynamic polymorphism. What is the advantage of dynamic polymorphism now? High level of abstraction. So that's how they'll continue one after the other. So you set your base correct, the next step you'll understand. If you understand that, then you'll understand the next concept. That's how they will continue. Understood now? So we are learning overriding now. Slowly I'll move to overriding. Then I'll talk about abstraction. Understood? So let's see the example now. Class demo. We are working with only two simple classes. Okay. So A is equal to new A. You don't have any questions with A. Reason is it's a very simple object. In A object there are only two methods, M1 method and fun method. Okay. And you can call both the methods A.M1. So what members you can access from the object depends on the type of reference variable. See, A is trying to access some members from the object. Which object? A object itself. Okay. So A variable is trying to access members from the A type of object. What members it can access? Again depends on the type of reference variable. So this is how it continues. I can access both. If I try to access something like show test A.show A.test, error I'll get. Correct now? That is clear? So what members you can access from the object always depends on the type of variable we take. But variable will always again depend on what? Class type. So this variable is designed to access only members of what? Class A. A variable has been designed to access the members of only class A, and you can only access that. You cannot access any other member there. Are you clear with this? Okay. So these two are clear. Now let's see how to work with B object. B is equal to new B. So now when the B object is created, see how the code works, M1 is there from class A, fun is there from class A, but again you are having M2 and fun from class B. This is B object. Present 4 methods, but I can access 3. Understood? Because see this, B dot M1, can I access? Yes, compiler checks, during compilation only it will checks. But see, what members can be accessed checks is depending on the variable type. But which one gets accessed is decided at runtime. So it checks in the bottom, doesn't find M1 in the bottom. That's why it will execute the method from which one, class A. B dot M2, again compiler compiles. Okay, but during runtime what happens? Okay, it checks in the bottom, finds from that only, executes. There's only one M2. But fun is not like that. See, there are 2 fun. Compiler will compile, but compiler is not deciding now. Compiler is going to decide. Compiler is not deciding which method to execute. It's a runtime environment which decides which method to execute. Understood? It's a runtime environment which decides. The JVM will decide which method to execute. B.fun, how it decides? Compiler will compile. You can access the member, but which member gets accessed is decided at runtime. So B.fun, it will execute from subclass now. Understood? Even though there are 2, it will execute from subclass. You can never execute the one from superclass. If you want, then you should say what? Super.fun. Now this is optional. Calling super.fun is optional. When will you do it? When you want to add functionality. If you want to change functionality, you will not be doing it. If you want to add functionality, you will be doing it. This is the route. Are you clear with this? So which method to execute? When is it getting decided? Runtime. This is only dynamic polymorphism. It binds at the last moment. Okay, which method to execute is binding at the last moment. Last moment means execution moment. Oh, the object is of type B. Okay, so the criteria for overriding is becoming what? Object. If you create an object of B, the method from B is executed. Are you clear with this? Okay, we'll go with one more class for your comfortableness. Once again, this is the correct code. Just I'll write super.fun properly. Now if you are interested, write super.fun. Else, leave it. Okay, now if you are happy with this code, use. Else you can modify now. What you will modify? I'll write beside here itself. Class C extends, or I'll write from the top. If in case I require D. If in case. So it will be helpful. Class C extends. Now what is happening here? B requires the logic of M1 from class A. Like one more developer now, what he wants? He wants the logic present in class A. M1. He wants the logic of M1 present in class A. He wants the logic of M2 present in class B. But he doesn't want the logic of fun present in class B. He wants M1 and M2, but doesn't want the logic of what? Fun method in B now. So what will he do now? So you can add an extra method that is optional. Then he can override void fun. Now again super.fun is optional. Okay, we'll see super.fun later. First we'll see without super.fun. See, C is equal to new C. Which object gets created? C object. What are the members of C? M1, fun, then M2, then fun, then M3, then fun. This is the C object. Like this you can create any object. Okay, now you can call the method C.M1. Can I access M1 with C? Yes. So this is how it will be working during runtime. Can I access M1 with C? So can I access will be checked at compilation time. Which one gets accessed is decided at runtime. Can I access? Compiler checks. Yes, it will compile. But during runtime, C.M1 checks in the bottom class. Doesn't find. This is only dynamic polymorphism. Understood? So depending on your object, it gets. This is the intro. Still dynamic polymorphism. It will open up. Still dynamic polymorphism. It will open up. This is this is not dynamic polymorphism. This is a stepping stone to what? Dynamic polymorphism. Just understand the criteria for overriding. Just understand the criteria for overriding. Always the criteria for overriding is what? Object. So it checks, is M1 been overridden here? No. If it is overridden, it would have been executed. Are you overriding it here? No. Are you overriding it? No. So then it executes from A itself. So see, M1 is executed from there, M2 from B, M3 from C, but fun from C it will execute. If you are not overriding fun in C, which would not have got executed? Fun of B. If you are not overriding here, it would have executed from A itself, like M1. If you are not overriding M1 in both the classes, definitely it will be given to superclass. Correct only, no? Logically. Understood? One more thing. Supposingly, now let's take another scenario. A wanted B wants logic of M1 and it wants to add logic to fun of A. So what will B do now? Extend, add a new method. Then what it will do? Override and say super.fun. So when you create a B object, M1 will execute, M2 will execute, fun both will execute. If you say super.fun. Now C requirement, he wants the logic of M1, he wants the logic of M2, plus he wants to add logic to fun of B. If he wants to add logic to fun of B, again he will override and say super.fun. So all the three methods will get executed. But sometimes C might do this also, like yesterday you put a question. I want, C does not want to use the logic fun in present of B. It wants to add logic to the fun method present in A. So that time what will you do? Instead of saying super.fun, you will say what? A is equal to new A dot fun, and then you can write your logic. SOP inside C fun. Means C decided to add logic to fun method of class A. Possible. Understood now why did you do that? Understood. C decides to add logic to, like this you can add the things in any level. Like class D can add logic to what? Fun method of A also. Class D extends C. There also you can do any modification. Like this, it goes on now. What you want you inherit, what you want you modify, it goes on. Understood? Work with simple examples, you'll understand now. C dot fun, what will happen now? This fun will execute, but what will fun do? It will create one more object of what? A. And there fun, but anyway, your logic is, you're adding logic to what? Fun of A now. So this logic will execute and then this logic will execute. But if I say super.fun, what will happen? The fun will execute from B class itself. But for A, new object will be created, remember that. Means, if I say A is equal to new A, new object will be, but anyway, what's happening now? First that fun executes and then our fun gets executed. So this is nothing but adding logic to fun of A now, without touching it also. Clear? This is how it is achieved. So you can go to one more level also if you want. Class D extends C. That's your wish now. Do you have any questions in this example? Your doubts getting clearer? Take simple examples. Your doubt? Any doubts? More examples I'll give you. These are the examples which you can see for overriding now. It goes on. Every day we'll override now. Whatever doubts you get, it will get clarified. But simply don't override. You know when to override now? When you want to add or change logic. Clear this? Any questions? Any questions? No questions? We'll see the output. You want me to show the output? No? Yes sir. You can type this now? Okay, fine, thank you then. But this is one sample code I gave you, like how things are getting executed. Shall I clear this now? Try it out. See, the best way you can learn is you type, not me. I know how to type. Understood? But you should learn how to type now. Yes or no? Shall I clear this? You have any questions? Any modification you want? You can try with another level, class D extend C. If you want to add, if you want you can override anything. I am just overriding fun here. In class D you can override what? M1, M2 and M3. Anything you can override. Which are not happy, you change. Clear? Okay. So, anyway, the criteria for overriding is what now? Object, you got that now? If I create C object, preference is given to first C. If I create B object, preference is first given to B. By chance, if I write class D extend C and override fun, DD is equal to new D, which fun gets executed? Class D extends C. If I means I can write extra method M4, that is optional, leave this. But if I write void fun, DD is equal to new D, which fun gets executed? From D class. I'm overriding, no. If it is not there in D, then it will execute from C. Understood? So it will execute from M4 is optional, you write. If you want, you write, else leave it inside fun of D. So this method gets executed. DD, if I create D object. So first preference is given locally. If not, it's immediate superclass. If not, it's superclass. And remember, in this flow, only one method will get executed. Even if I create an object of D, when I call fun method, even though there are 4, only one gets executed. So method execution is like this. Among all the methods, only one method will execute. Until and unless you call explicitly which one? The superclass method. Until and unless you call explicitly the superclass method. Understood? But constructor is not like that. All the constructors in the hierarchy will get executed. All the constructors in the hierarchy. Understood? But method only one. Clear that? So and constructors are executed during instance creation time and methods are executed after the instance creation. Clear this? You are clear with the difference between the constructor execution and method execution, huh? So when anybody says dd is equal to new d and say dd is equal to new d, and if they say dd is equal to new d and they'll say d dot fun, what will be the output? Only inside d. It will not be what? Inside a, b, c, d. D dot fun will not print what? A, B, C, D, it will not print. But constructor, yes, definitely inside A, inside B, inside C, inside D would have got it. If you want to add constructors and check. Understood? If you want, you can add constructors and check. Understood? It will execute all. But method only one. Are you clear with this? So in the hierarchy, all constructors are executed. Method only one will be executed. Understood? Depends on the object. That depends on the object. If it is not there in bottom class, superclass. If it is not there, then it's superclass. If it is not there, then superclass. Clear? Any questions here? Okay. I'll clear now. We had written one classes, which one? Box weight, shipment. Yes, let's get into that example. No? Sample I'll write, I'll not write it in detail. You know how to write the class box. You will have 3 instance variables. I'm just focusing on the which one? Methods here. You know how to initialize this. This dot w is equal to w. This dot h is equal to h. This dot d is equal to d. You can write one more constructor. You can write one more constructor. Okay, now if you want, you can write the volume method. That is optional. You know how to write the logic, right? But if I am interested, I can write on M1 method now. Why are we writing this M1 method? To print values of W, H and D is plus W plus H plus D. This is how you write the logic now. Okay, now let's inherit now. And we'll see how to add methods now. Into which one? Subclass. So when you write a subclass, you can have a variable. That's a very good example now. You can have constructors and you can write methods. Now we are seeing the combination of all the 3. What? Variables, constructors and method. Now how will you decide to add a variable? I want an extra value to be stored now. So I will decide to add one extra variable now. See, this is how you modify a subclass. Means this is how you write a subclass, sorry. This is how you modify a class. That is one thing. Or this is how you modify an existing class. See, get the 2 point. This is how you modify a class. I can say it in that way. Okay, without touching only you will modify. That is one way of telling. Another way I can tell is, this is how you write a class. Are you understanding the difference? Modifying an existing class, writing a subclass. Almost all similar. Understood? You write a subclass for modifying an existing class now. Why do you write a subclass? For modifying an existing class. Okay, that is one reason. Why do you write a subclass? For inheriting. Understood? Yes, class box weight extends what now? Extends box. Now what is the extra member you want to add? Add int weight. Now you want a constructor, add. How you initialize? You know, super of WHND. And this dot, and take the variable name is, I've taken weight now, int m I'll take. This dot, I'll create conflicts, is equal to m. If you want, you can write one more constructor. So everything is fine in this class, but I want to write an extra method. The method I want to write, which extra here is, I want to print the value of which one? M. That's the only method I want to write. So what will you do now? Will you write M2 method, or will you, what will you write? A new method, overload, override, what is your decision? It's better you override this time. Why? See here, void M1, I'll override. And here I'll say super dot M1. Valid now. And I'll say SOP value of M is plus M. That is adding logic. Understood how to write methods in subclass? You should know how to write. You can have variables, you can have constructors. Okay, methods you decide now. Apart from writing M1, you can write one more extra method now. Just I need space, I'll remove this, plus WHND, I'll write it this side. So this is M1 in class B. Okay, now see extra method you want, you write void, something like test. That's your wish. Write anything. But here I am overriding, here I am writing completely new logic. So now see, for seeing the values in both the objects, I will not write, see PSVM, see box B is equal to new box of 1, 2, 3. I have created which object? Box object. Means you know how the memory gets allocated. But to see the values in the object, I will call what? P dot M1 method. Same method now. Finished. But if I want, see now, if I will work with box weight object. Box weight BW is equal to new box weight of 5, 6, 7, 8. So see, this is box object. It was having, concentrate on only the method M1. I am not writing the constructors and all that. So B dot M1 it will print WHND. But if I say box weight BW is equal to new box weight, which object is created? WHND, there is an M1 here. Sorry, volume also is there. Sorry, I am not focusing on volume, but M1 is there, plus which one is there? Volume is there in class B, plus M1 is there, plus M is there, plus M1 method is there. These are the members of box weight. Plus, sorry, test also is there, na? Extra method. These are the members of what? Only I have not written constructor. So BW.M1, which method will be called? The one in subclass, na? What will the subclass method do? Invokes the method of superclass. Very simple. So for printing the values, okay, I have given the same name. I could have given a method name by name M2. But remember, you have to remember two method names now. For printing the value, you have to remember what? In box, you have to remember M1. In box weight, you have to remember M2. That becomes a headache. Understood? So if you want to add logic, better is what? Don't go with different names. Understood? Don't go with, if I change the method name, this is a headache. So that's why to add logic, so here preferably I wanted to add logic. So instead of going for M2, you go for M1 method. Now it's easy. Not only there, if you want to create shipment object now. Class, shipment, extends, box weight. Okay, int, cost, shipment int w, int h, int d, int m, int c. So it has 5 parameters. Super of w, h, d, m. You know which constructor gets. You know the flow of constructors. That you know. But here also I will have what now? M1 only, which will print what? Value of c. But I am just adding logic now. So here I will say compulsory what? Super dot m1, because I want the logic of m1 in a also, sorry, box also, m1 in box weight also. Very clear. Practically you are seeing now value of c is plus c. Are you understanding now how you write this logic now? And he says shipment s is equal to new shipment. I am writing shortcut. Shipment s is equal to new shipment. Okay. Now write 10, 20, 30, 40, 50. There are 5 values you are sending. The shipment object gets created. W will be there, H will be there, D will be there. Wall plus M1 is there from superclass. Then you are having M and M1 from which one? Box weight class. Then you can have again C and M1 from shipment class. S dot M1, what will this M1 do? Invokes this M1. What will this M1 do? Invokes this M1. It will print all the values. But you are remembering only one method now. Adding extra method in shipment is possible. Okay, you can write an extra method. Instead of, again after M1 you can write something like void, something like fun. That you write extra, that is optional. But I am overriding M1. Why? I wanted to add logic to the member of which one? Box weight. I wanted to add logic to the M1 method of box weight. M1 in box weight wanted to add logic to M1 of box. So this is how you go on adding logic. So this M1 is adding logic to this M1. This M1 is adding logic to that M1. Here, if I want to add logic to box M1, I have told what? Box B is equal to new box B dot M1. That's all. So that time you are adding logic to what? M1 of class box. But that very rarely happens. Always it happens like super dot M1 only will be telling. Understood? Always generally what will happen? It will be calling the immediate superclass. Generally. Because practically I am telling you now. Even though you can invoke it, but practically you will be always invoking the immediate superclass method only. You can invoke any method in the hierarchy. But generally we invoke the immediate superclass in the hierarchy. You will understand when I give more examples. Yeah? Any questions here? You understood how to write subclasses? So how do you understand now? So I am teaching you how to write what now? Subclass data type. Why do you write a subclass data type? Many reasons. To modify an existing class, or to inherit the features, or to establish is a relation. Understood? Box weight is a box. Okay, that means you start inheriting. Understood? Are you clear with this? So there are many reasons why you write a subclass. And how do you write? We want to add extra, means see how you go on adding extra members. How do you modify? Adding a variable, extra variable. If you add extra variable, what you should do now? Write constructors to initialize it. I am writing constructor. Now how many constructors you write to initialize, that's your wish. But I am showing you overloading. All in one example only you are saying. Now after overloading I want to write a method. But when I am writing a method I should know what logic is needed. Okay, I want to add logic to the method of superclass. That is my requirement. I don't want to write M2 method here. Because if I write M2, what is headache? To print the values in one class, I have to remember one name. So that's why I will override. And after overriding, I will call which one? Super.m1. So any object you create now, box B is equal to new box, or you will say B.m1. If you create box weight object, again you will call BW.m1. Shipment S is equal to new shipment S.m1. So in this example, I am forced to add logic. I do not want to change logic. If you wanted to change logic, very simple. Don't call what? Super.m1. That's all. One line you remove. Clear this? Still more examples I'll give on overriding. Don't worry. You'll get very clear idea. But are you getting the idea of deriving subclasses? Okay. Now shipment. What was the requirement? It wanted all the features of box and box weight. So instead of writing whole story again, it inherited. Which one? Box weight. What it wanted extra, it added. What was the thing it wanted extra? C. When you add a variable, then definitely you have to write a constructor now, which will initialize what? All the variables. So you are having totally 5 parameters now. W, H, D, M, C. Why? Because there are 5 instance variables, 3 in box, 1 in box weight, 1 in shipment. You know how to initialize now. Super, you will carry the values, and the current value will initialize here with the help of this dot C, because there is a conflict. Initialization done, but I want to write a method, but this method again should print what? Values of all. So instead of print, I want to reuse now. So what will I do? Super dot M1 I'll say, and then I'll print the value of C here. That's it. Are you clear with this? Understanding how to write subclasses? So writing a class also is on big art, writing a subclass also is on big art. If you know how to write these 2 data types, other 2 are very easy. Which one? Abstract class and interface are very, very easy. You don't have to worry about that. Yeah? So this concept is true in C++ also. Even in C++, if you want to study inheritance, you should have studied like this. But in inheritance, how do you study in C++? Man extends dog, dog extends man, you study like that. That is wrong. Means that is theoretically you study. And you will never understand inheritance like that. Inheritance, yes, theoretically you study little. But next again you have to study what? Practically like this with examples. So all the examples, see, we learned encapsulation, we are learning polymorphism, we are learning abstraction, we are learning inheritance, all practically. Now here, I will explain what is abstraction in subclass data type. See, once I create box weight, BW is equal to new box weight, BW.M1, I am getting the answer now. I am getting the answer now. How I get? Somebody has written, see, I wrote this class, you will call my method, which one? BW.M1 also you can call, you will create the object. And you will call M1 method also, you can call volume method also. Volume method is from where? Superclass, both the methods you can call. You are getting the output now. How I have written the logic, why are you bothered? Understood? That is itself abstraction. Abstraction means unclear. You don't know how you are getting the output, but you are getting the output. So to achieve abstraction, which is the data type you are using this time, subclass. So subclass is doing encapsulation, yes or no? Now see, subclass you see from OOPS point of view. You are encapsulating the value of M. M has been encapsulated, now hiding data. Understood? Earlier class was hiding what? WHND. Okay, and now what we are hiding? M value. Understood? So it's hiding data. Means once I get the value, I store it in one location. This is hiding data, encapsulation. Then polymorphism. Yes, we are seeing overriding here. Encapsulation, polymorphism. Then we are saying inheritance. Then we are saying what? Abstraction. Box weight BW is equal to new box weight. I have written the class. You are using my class. Okay, BW.M1 you are getting the output. BW.volume you are getting the output. Why should you bother now you are getting the output? Your duty is what? Use it now. Use it. If you want to see the match, you buy the TV or invent TV. As simple as that. Answer to this. How it works we don't know, but that is abstraction. Same way here, if you want any code, if it is existing, use it. Why do you want to write it? If you want any code, if it is ready, use it. How it works is abstraction for you. You don't have to sit and reinvent the wheel again and again. Understood? Anything which is there, directly start using it. Clear this? Anything which is there, directly use it. TV is there, use it. Watch is there, use it. Okay, just because I want to see the time, I will not sit inventing the time. Watch now. I want to see the match, I will not, means cricket match, I will not sit and invent the TV. Okay, I want to go to Delhi, I will not sit and invent aeroplane now. So whatever existing things are there, we start reusing it. Same way in Java also, if any code is there, start reusing. And Java's reusability level is high. If anybody has written a class once, it can be used in anywhere, any operating system, any processor, anywhere. That is the level of reusability Java provides. At the same time, it is supporting you abstraction also in a very high level. Because of reusability only, what is coming out? Abstraction is coming out now. Okay, now if you want to implement OOPS, we have studied 2 data types now. If you want to implement OOPS, you can use class also, you can use subclass also. Now if you question me why they are given two data types, answer is simple. What is the answer? Class you will use when you want to do new concrete implementation. Subclass you will use when you want to add or change implementation. So both are data types provided for implementing OOPS only, both. There is no difference. But scenarios will define when to use which data type to implement OOPS. Are you clear? So in Java it is very, see, OOPS is on big subject. Java is supporting OOPS in this particular way. Understood? Don't think you are learning Java and OOPS. You always understand that you are learning OOPS in Java. How to implement OOPS, we are studying it in Java. It is the reverse. OOPS in Java you are studying. Don't study Java in OOPS. full confusion will come. First understand what is OOPS, and that OOPS how is getting supported by Java. Now once you learn OOPS here, you can learn C++ also. Same story will be there in C++ also now. Nothing difference. But there it is very bad. Okay, what all things are bad in C++ we'll discuss later. First we'll study one properly. Once you know one thing properly, then you can study the improper thing and understand the improper thing also. What is bad in C++. Clear this? Are you clear? So now you should know how to derive subclasses also. Okay, see, if I even now also if I give an example and ask to write the code, you will not be able to write. Simple is, you need still more exposure. Still more exposure. So slowly the day will come when you can write classes on your own. Okay, but generally see, you had the idea. You might be from any stream, CS stream or electronic stream, whatever. You had the great confidence. You can write a class or subclass. It's very easy. It is not like that. Okay, you should understand, because anybody when they ask you to write any code, first what you have to say is the code existing. That you have to decide. If the code is existing, directly create an object, use it. If it is not there, then write your new class. That's how you have to write. Understood? Supposingly if it is there, you want to modify, then write subclass. So this is how you take decisions and write the code. But when anybody asks you to write the code, don't blindly write off class A. Start writing code there. Okay, so that is not the way. So that is what we'll start seeing now. In the coming classes, you'll clearly start understanding how to write, or when to write class, when to write subclass. That you'll start clearly understanding, and then you'll start writing also. Okay, so that is why we are not learned till now how to write any logic. Because to write logic, we have to use the data types. And when you use the data type, you should know which code to write where now. Whether you'll write that code in a static block, instance block, constructor, methods. Okay, so all this you should know now. Clear this? Okay, so what are the different members of the subclass we studied? Instance variable, constructor, methods, we studied 3. If you want, you can add blocks also. Yes or no? That I covered in the very first example, nearly. You can write static block and instance block here also. You can write static block and instance block here also. You can write static block and instance block here also. If required, write. No issue. Understood? That is optional. But that's also on possible member. But you know the execution now? How they are executed? If I say shipment S is equal to new shipment, you know the flow now? First A class is loaded, then B class is loaded, then C class is loaded. Then A instance, A constructor. B instance, B constructor. Shipment instance, shipment constructor. I'll give you an example for that. Do you want me to repeat that, or it's fine? You can refer to that example. Are you clear with all this now? Okay, so you have understood how to write subclass, and we have seen all the possible members now. That's all the possible member now. Extra member, what you have to study now? Static. You can write static members in subclass also. Static variables also you can write. Static methods also you can write. That's it. Understood? Are you clear with this? Shall I clear this example? Shall I clear this? So instead of writing M1, M2, M3 in all the classes, what do you write now? M1, M1, M1 you write. Clear? Earlier I was writing M1, M2, M3. In M3 I was calling M2. In M2 I was calling M1. It's not correct. So that's why in subclasses do not invoke, means in different methods of subclass, do not invoke the method of superclass. It's adding logic. We know that it was getting executed, but we always call superclass methods in overridden methods of subclass. Overridden methods. Do not call superclass method in any method of subclass. Clear? I'm justifying why you use super dot now for methods. Yeah, I told you, means from OOPS point of view, no. You understood inheritance and all that. But OOPS point of view, what does OOPS say? For generalization, use what? Superclass. Correct? That means general things keep it in superclass. For specialization, it says use subclass, right? I'll give you an example for this. Let's see. Means from whose point of view I'm explaining now. From whose point of view. Till now we studied inheritance, subclass data type, all we studied. From whose point of view, a simple example I'll give. See this. There's a class called as animal. Okay. Eat method. Okay. Simply I'm writing on some characteristics now. You can add some features. Animal SOP. Animal is eating. Void walks. SOP. Animal is walking. See, this is generalization. Anything which is general to all animals, I'll put it into one class. Specialization now. Class dog extends animal. So this is specialization. Void sound. Is extra now? Or 1 second. Mark I'll take. So it will inherit both the features, plus it will add what? Extra features. Understood? It will inherit both the features, plus it will add. This is specialization. Again you can say class cat extends animal. Here you can add whatever its characteristics. Okay. Void eyes. Simply I am writing, don't write such kind of examples in which an interview and all that. I do not give such examples because in interview you'll start talking what? Dog, animal only. Then you'll be, means the Java interviewer will get confused. Am I taking Java interview, means with I'm taking interview with a Java developer or with a zookeeper? Understood? Just I'm telling you one simple example because you are not zookeeper, no? Okay, just I'm giving you eyes. So SOP, brown eyes, something like this. So extra characteristics you can go on adding like this. So this is specialization. So the general things you'll keep it in one class and then you start inheriting. Now cat was not extending dog, no? This is hierarchical. Understood? So how you want, you can go on inheriting. Either you go for multi-level or you go for hierarchical. Avoid using such kind of examples, but in books, any book you see, they'll give such kind of example only. Any book. You take any book, they'll give such kind of example only. Why I don't take such kind of example is because later on, after some months, you'll go with, means you'll try to go with experience and all that. Okay. So that time what will happen? They'll be asking you, explain OOPS from project point of view. Now in project, if you start telling dog, animal and all that, you'll start worrying now. Have you really done the project or are you coming from the zoo? Understood? So these problems will come up. So that's why we don't take such examples. But many places they teach such kind of examples only. Okay, so that's why I didn't teach you like this. I thought in a different way. What did I teach? Subclasses are used for a modification of classes or all that story. Why do you use a subclass? You know that now? You tell it in a different way now. Subclass is used for generalization. Tell that. Sorry, subclass is used for specialization. Subclass is used to establish is a relation. Like that you tell. Subclass is used for modification of existing classes, or subclass is used for inheriting the members of one class into another class. Like that you have to tell. Understood? And they ask you how do you modify an existing class, then all the story you can tell. I can extend, I can add variables, I can write methods, and when I write a method, I'll either override, I'll either overload, or I'll write either a new method. All that story you can tell. Yeah? So you have to talk subclass in that words. Those words you have to use. They look more professional and technical. Yeah? One simple example for showing you generalization and specialization. Done now? Will not talk about such example. But are you understanding the two words generalization and specialization? So you know relation between classes. In relation between classes means you will have many classes. How do you relate them? Either with is a relation or with has a relation. Okay, in is a relation you are having something called as generalization. See, this is OOPS point of view. Generalization, realization. I clear all this now? I have written this table for you, remember that? Generalization, realization. Okay. See, if you want to, means, like this here, I'll clear this also. I'll explain what is user relation and hazard relation now. See, if there are two classes, dog and animal. Dog, animal. So how will you relate it? Is or has? Dog is an animal. So that time you will make animal as superclass, dog as subclass. Understood? You should know how to relate. Dog is an animal. Okay. Then next, something like BMW. Car. What will you do? So car you will make it as superclass. See, this side you start making superclass, and this side you will start making subclass. So this is generalization. Means this is specialization. And Maruti is a car. Getting it now? Maruti is a car. Like this you can write anything. Yeah? You know examples for has also. Now car and engine, how will you relate? Car is an engine, huh? So you are good in English, I think. At least you are good in English. Now you don't know Java, I understand. But you are very good in English, correct? Huh? Yes or no? Because 22 years you have studied for one language, how many days you require? Hardly 1 month is sufficient, no? To learn Java language, how many days are sufficient? 1 month, no? So when you can learn one language in 1 month, why can't you learn English in 22 years? So you're professionals now. Yes? So you only tell now. Car has an engine. So if you know this, it's very simple now. What will you do now? Class, car. Okay, engine you will write another class. And you will make engine as instance variable. You will write one more class called as engine. And you'll, okay, here you might add extra properties, but engine is the instance variable of car now. Same way, employee has a dress, employee has a phone. Understood? So like this, when we write projects, when we do projects, you should understand now. When there are two classes, they will be independent, and means two independent classes we write off. After writing independent classes, now one class has to use the other class. Otherwise, what is the use of writing so many classes? So definitely they will be related in only two ways, no other way. When you are having two classes, you have to relate them in one or the other way, and that is done with the help of only is a relation and has a relation. There is no other way you can relate. So for has a relation we make what? Instance variables. Okay, but fine. Again, here also it's on big subject. What is that? Aggregation, composition. Composition means what? Complete dependency. We will be seeing examples for this later. Theoretically I am telling you now. Aggregation means what? Partial dependency. Complete dependency means what? University has a department. Correct? Now department cannot exist without what? University. One more example. Car has an engine. Correct? Engine cannot exist without a car, like that. Okay, you can write. But then partial dependency, department has a lecturer. This is partial. Understood? This how means if you want to establish has a relationship, we use instance variables. Do not forget that. Oops says if you want to establish, oops is telling that. Understood? If you want to establish has a relation, use instance variables. Again, same oops tells if you want to establish is a relation, there are two things: generalization and specialization. Sorry, realization. Okay. Anyway, we'll see realization later. One of the way to implement is a relation is generalization. Means generalization. Okay, and here only you get specialization. There are two things which will come out here. Generalization is, see the data type supported now. For generalization, Java is giving which data type? Superclass. For specialization, Java is giving which data type? Subclass. For establishing has a relationship, Java is giving which data type? Class data type. Understood? This is one class, that's one class. We'll establish has a relation. So for establishing has a, this is class data type has been given to establish has a relationship. Superclass data type has been given to establish generalization. Subclass data type has been given to establish specialization. Very clear it is. This is from OOPS point of view. If you want to study OOPS, this is OOPS. Understood? Anyway, don't learn OOPS because you don't know OOPS. You can't learn also. Yes or no? Because these are all new words. Okay. If you are not following this, forget it. Slowly you'll gradually understand all these things later. Because we have to still see more things. We have to understand what is realization. For supporting realization, you know, which is the data type given to your interface. We'll be saying realization later. Interface data type has been supported for realization. So all data types are seen here. Not only this, you can also use abstract class here. So both abstract class and interface can be used for realization. We'll be saying this very clearly. So you have got 4 data types. So from OOPS point of view, this is how they are designed. 4 data types. But in C, you don't have a proper support for all this. The same problem in C, you do not have a good support. Understood? It's a very simple story. It's a very, very, very simple story here. You have got 2 classes and how you are going to establish the relationship between 2 classes. That's a very simple story. Either with has a relation or with is a relation. Clear? This is all a very simple story. Clear this? Clear? This part little tough only. Reason is your design principles are bad. There is something called as OOPS design. Okay, generally till now you have learned OOPS in what way? How did you learn OOPS in your lifetime? Like this: university, department, car, engine, like this you have learned OOPS. Obviously from that terminology, if I bring you into this terminology, it is difficult only. So you have to understand the words, terminologies first. Once you understand these terminologies, automatically you start understanding all this concept. Okay, but this is very high level what I am telling you. In fact, people with 2 years, 3 years of experience, they talk like that. Minimum 3 years or 4 years of experience, they talk OOPS in this way. Freshers and all, you and all, it's very tough. It's not that you can't do it. You can also do it, provided you read more books on what? OOPS design principles. Only purely OOPS you study. Purely OOPS. Don't study Java. There are special books written only for what? OOPS design principles and all that. There you study, you'll start getting all this. But directly studying OOPS is very difficult again. First you have to study somewhere and then study that book. Then you'll clearly understand all that. Understood? So it'll take some time. Don't worry. We'll be seeing all this. Everything I'll only clear it for you. You don't have to worry too much also. All these things I'll only be clearing it for you. But it takes time for you. Yeah? Shall I clear all this now? Yeah? Okay. This is done. Yeah, we'll move to the next important subject now. This is the, after learning all this, after this concept, one more concept you have to study. After learning this concept only, you start understanding something called as dynamic polymorphism. This is also one more concept. Very crucial concept, very crucial concept. Okay, write it. A superclass reference variable can refer to subclass object. A superclass reference variable can refer to subclass object. A superclass reference variable can refer to subclass object. A superclass reference variable can refer to subclass object, but what members can be accessed from the subclass object? But what members can be accessed from the subclass object depends on the type of superclass variable. Depends on the type of superclass variable. see this. A superclass reference variable can refer to subclass object. But what members can be accessed from the subclass object depends upon the type of superclass reference variable. Very new story this one, we are going to see. Understood? Very new story, but most important story. Understood? This is a very, very powerful concept, and the advantage of this is, what is the advantage of this? Okay, right now you are not understanding the point, I know, but the great advantage of this is it supports dynamic polymorphism. Then it supports something called as decoupling. I'll be explaining all these words. It provides high level of abstraction. Advantages of this. So first we have to understand this point. What point? What I have written on the top. After understanding this, then you will understand this. They are all linked, interlinked. Understood? So first I will be explaining you this. When I teach you this, you will think, what is the use of that? What is the use of that means? These are the three uses. Understood? First we will understand this point, then you will start understanding what are these three things. Clear? When I teach you this, it looks, so what is the use of that? But that use I start teaching you in the next classes. That use I will be teaching you in the next classes. What are all the uses? Okay. And one more thing is, yeah, write this much, right? Fine. Shall I clear this? These are advantages of something like this. Superclass reference variable referring to subclass object. Advantage of superclass variable referring to subclass object are three advantages. Clear? Advantages of superclass reference variable referring to subclass object. Reference variable. Reference variable. Clear? I'll clear this now. You can write there only one more line. See, I am going to derive this formula now. There only wrote the notes now. Superclass variable can, there only write this line. Till now A is equal to new B is what? Error now? Till now this was error now. Can you create B object and refer it with A? Till now not possible, but now it will become possible. But under one condition. Under one condition it is correct. What is the condition? Means A should be compulsory superclass, B should be compulsory subclass. That is the first rule. Okay, if this is like, if it is superclass and if it is subclass, this is possible. Understood? That's the meaning. See, this the meaning is a superclass A is what here? Left hand side. See the equals operator, assignment operator it is. Okay, this is assignment operator. And new B means what? It's an object. Finally object means what? Reference value now. Actually what are you trying to do now? You are trying to give the reference value of B to A. You are trying to give the reference value of type, means reference value of one object to one variable. But here this will work provided the condition is this is subclass object. So you can give the reference value of subclass object to superclass reference variable. That's the meaning of that statement what you wrote now. You can give the reference value of subclass object to superclass reference variable. Understood? This is possible. It is possible to give the reference value of subclass object to superclass variable. Now see this. This is superclass. One more point now. This is superclass reference variable. Getting it now? This is superclass reference variable. What is this now? Subclass object. Only under this condition this is true. If they are not related, it is false. If A and B are not related, it is false. So theoretically I explained you. But again, what do you need? Example to understand that concept now. So next I will show you the example. You need an example to understand this now. Clearly you want to understand. So I will give an example. So first I will teach you the example. Then I will teach you what is the advantage of this. Advantage of this is what? Three things. Understood? Clear? This is first one. This is superclass. The condition I am telling you. This is condition. Both this should be superclass. That should be subclass. Again, this should, if this is a variable of which one superclass reference variable. This is a variable of object of what? Subclass. This is a superclass reference variable. This is a subclass object. Are you clear with this now? Are you clear? Superclass. This is subclass. Superclass reference variable. This is what? Subclass object. Yes, we'll see an example now. So all new concepts starting off in inheritance now. See class A, int x, int y, void fun, or m1 I'll take, much simple. I think see there are two classes, A and B. It is extending. What is happening? Class A is there, class B extends that. So now let's see how it works. We are not using constructor here, leave it, no problem. Okay, but I want to show you one concept. Do you know how to work with, see till now you have learned working like this. If you create if you create A object, you are referring that object with what? A kind of a variable. But I had introduced some terminology, if you remember. Here, superclass variable is referring to superclass object. Yes or no? These were the words I had used when I initially introduced you. So in this statement, what happens? An object of A is created. What are the members of A? X, Y, M1. So what kind of an object is this? New A? Superclass object. The address of that superclass object is given to which one? Superclass reference variable. Address might be 150. Example. So here you can see superclass reference variable is referring to superclass object. Okay. I could have initialized with constructor, but do not bother. I'll initialize with dot operator. Don't worry. Okay. So here we are not bothered about initialization. We are bothered about the concept. Which concept? Superclass variable referring to subclass object. That concept we are bothered now. So A dot x is equal to 1, A dot y is equal to 2. Valid. Understood? So A dot x is equal to 1, A dot y is equal, it will overwrite. Initially it will be 0. When you created the A object, it will be 0. Now it overwrites to, you're following now, you know the initialization, huh? Initially when you create the object, A is equal to new, x and y are what? 0. When I initialize with dot operator, they are overwritten to 1 and 2. And I can call M1 method also. Till now this is how we have worked. Just revising it for you. You know all this. There is no problem with this. Now look at another line. B is equal to new B. So I am creating which object now? Subclass object. So what are the members of B now? See, X, Y, M1, Z, M2. And I can give the values. B dot X. But what is the story? Sorry, address is 250. That is given to B. So what is the object of type? Subclass object. B is a variable of type what? Subclass. So this is subclass reference variable is referring to subclass object. Subclass reference variable is referring to subclass object. Getting it now? Subclass reference variable is referring to subclass object. Here superclass reference variable is referring to superclass object. Means object and variable are of same type. There's no problem. This you know already. And I'm trying to, see, don't think I'm trying to initialize and all that. See how we are working with the object using the variable. And I can access all the members. See this, b dot x is equal to 5, b dot y is equal to 6, b dot z is equal to 7. Valid. Understood? So A is a different object. Initially these were 0, they are changed to 5, 6, 7. Any questions here? And I can also work b dot m1 also I can call, b dot m2 also I can call. Valid code. Understood? So now A is referring to, A is a superclass reference variable. It is referring to what? Superclass object. B is a subclass reference variable and it is referring to subclass object. Perfect. No questions till here. Clear now? This is what you have learned till now. So we learned how to work with subclasses. We learned how, till now what I am revising. We learned how to write subclass. We learned how to create objects of subclass. We learned how to access members of subclass. Writing subclass we learned. Creating objects of subclass we learned. Working with the subclass reference variable also I have taught you. Till now any questions? No. Fine. So we'll go with the new point now. So A is a variable, B is a variable. Yes or no? So now see this. I can say this. A is equal to B. Highly valid statement now. What are you trying to do? You are trying to give, means you know we have done something like box B1 is equal to new box. Box B2 is equal to B1. Box B3 is equal to B1. Remember that? What were you trying to do there? You are trying to use the address of B1 to B2, B3. We had created one object, if you remember. B1 is equal to new box. Then I was telling box B2 is equal to B1. Box B3 is equal to B2 or B1. So one object, but all the reference variables were referring to the same object. Same thing here. You got two objects. But now what am I trying to do? Trying to give the value of B to A. This is possible. You are trying to give the reference value of subclass object to superclass variable. Possible. Technically, if you see what it is called, a superclass variable, reference variable can refer to what? Subclass object. It is possible and A will get dereferenced. Yes, earlier it was referring to this, but now it will refer to what? Leave about the dereferencing. That you don't bother now. A getting dereferenced, don't bother. Earlier it was referring to this object, but now it will start referring to what? This object. Subclass object. When it refers to subclass, it is referring, sorry, one second. Just let me write it again. So A is referring to this, now it's not referring to this. You print SOP A. You print SOP A here, it prints what? 150. You print SOP B here, it prints what? 250. Both are different address. But if I print SOP A here, it prints what? 150. Check that. Sorry, 250. Because A is referring to this particular object. Clear? It is referring to B and it is definite now. So this is possible. So this is the first statement what I told you now. A superclass reference variable. Correct now? What is A now? A reference variable. See, left hand side is always variable. Left hand side is always variable. In the assignment operator, left hand side is always variable. But what type of a variable it is? Reference variable. It is not primitive variable, no? It is reference variable. What is the difference between primitive and reference? Primitive variables hold primitive values. Reference variables hold reference values. So this is a reference variable. But this is a reference variable of type what? A. Now what is A? Superclass. That's how we say. It is a superclass reference variable. Justified? You understood the definition of superclass reference variable. Okay. Now what is B? Reference value. Means object. Understood? What is B now? Subclass object. It is a reference value of subclass object. It is a reference value of subclass object. So superclass reference variable can refer to subclass object. Valid code. First you understand this. 100% it will compile. But only one change I will do. Remove extends A. That is error. I will come back to this point later. If they are unrelated, that is wrong. If they are means box B is equal to new hello, correct? Huh? Understood? Not correct. Means they are two different. But now, if they are related, this is correct. We will come to that not relation later. Now once it is related, now I can work with A. Means to work with this object, I can use A variable also, B variable also. Same concept you have seen when you say box B1 is equal to new box. one object was getting created. This was B1 object. Now the same address you are giving to what? B2 also, B3 also. This is what we learnt. To work with that object now, I could have used what? B1 or B2 or B3. The same way to work with B object, subclass object, I can either use A variable or I can use B variable. Any variable I can use. Understood? So now, I found I'll work now. SOP, don't think I'm printing. Check what members you can access. A.X, valid code. SOP, A.Y, valid code. A.M1, valid code. A.Z, A.M2. These two it will give error. See, this is correct, this is correct, this is correct. This is wrong, this is wrong. Means A variable can refer to the subclass object, but it can access only the superclass members. But it cannot access subclass members. So that's what I told. What members you can access from the object depends on what? The type of variable. Getting the point now? What members you can access from the object depends on the type of variable. Understood? When a variable is referring to an object, what members can be accessed from the object depends on the type of variable. So A is a variable of type A, and you can only access the members of class A. Correct? Because superclass does not know anything about subclass, no? Superclass doesn't know anything about subclass. So that is why with A variable you can't access the subclass members. If you want to work with subclass members, which variable you will use? B. See, there are two variables referring to the same object. But difference is, with A you can access only these members. With B you can access all the members. Right now which looks advantageous? B. Understood? If B refers to that object, it is advantage. Why? You can access all the members now. But if A refers to that object, what is the problem? You can access only superclass members. Okay. Right now you think B is only good. But later on you will understand. Scenarios will decide whether A referring to the B object is good or B referring to B object is good. Both are correct. But sometimes we write the code as AA is equal to new B. But sometimes we write the code as BB is equal to new B. Both are correct. Understood? So anyway, are you clear with this formula now? So that's how the formula comes out now. What? See, instead of doing like all this story, I could have done it in what line? One line. I could have written AA is equal to new B. Yes, this is valid code. If I say AA is equal to new B, what happens? Object of, forget all this now. Just focus on one line. Which line? This line. That one line, forget everything what I thought now. So when I create new B, yes, new B object is getting created, no doubt about it. Z is there, M2 is there, and default values of X, Y, all are 0. And the address of this 150 or whatever it is given to A. Valid. Highly valid. But with A, I can access only 3 members. Which 3 members? X, Y, M1, that's all. Z is present, M2 is present, but I can't access. See, presence is different, accessing is different. Even though the subclass members are present, I can't access because I am using superclass reference variable. If you wanted to access the subclass member, you should have created what? Subclass object and referred it with subclass variable. Then you could have accessed. Are you following now? So AA is equal to new B is correct, but I can access only this. See, I can initialize. What I will initialize? A.X is equal to 10, A.Y is equal to 20, A.Z is equal to 30, error. I can't access. Can't access. A.M1 executes, A.M2 error. When error? Compilation time. Understood? So what members you can access from the object always depends on what? The type of variable. That's what I am trying to explain you now. Understood? You can, what members you can access. So in the object, many types of members will be there. Many members, extra members will be there. Why extra members will be there? Because you have created subclass object. If you create the same object, no problem. You will have the same numbers. Number of members will be same. But now we are creating subclass object. So subclass object will have extra members. But if you refer to that subclass object with superclass reference variable, okay. Now superclass variable can access only superclass members. Clearly I have defined the statement for you. A superclass reference variable can refer to subclass object. But what members can be accessed from the object depends on the type of superclass reference variable. Clear this? I'll type and show you this. Are you clear? Okay. Now, what happens if, okay, one more thing we'll see. So all this is clear now? I'll revert back. Let A refer to this only, let B refer to this only. We'll come back to this program here. Which program? This program. A is equal to new A, B is equal to new B. A is equal to B correct, but B is equal to A is wrong. Ulta is not possible. Means subclass variable cannot refer to superclass object. Subclass reference variable cannot refer to superclass object. This also you should understand now. Why? Technically you only see it. If B is equal to A, you are trying to give what? The reference value of A to B now. If by chance B refers to this, where are the B members? Z and M2. So superclass object will not have subclass members. Superclass object will not have subclass members. So there is no use of making subclass variable refer to subclass object. Sorry, superclass object. There is no use of making subclass reference variable. Subclass reference variable. What is this now? Subclass reference variable cannot refer to superclass object. So this is wrong. Subclass reference variable cannot refer to superclass object. Why? It is clear. Superclass object is having only superclass members. So what is the use of making subclass variable refer to that superclass object? But here ulta is correct. A is equal to B. Why it is correct? Because you are not able to access subclass members, fine. But at least you are able to access which one? Superclass members, no? When you say A is equal to, see, when B is equal to A, it should satisfy all the conditions. It's not satisfying because there are no members of B. When B is equal to A. When B is equal to A, if B refers to A, where are the subclass members? So it not, if it is satisfying the condition, they could have done it. But the thing is now, A can refer to B and it will satisfy the condition. You can access the members of all A now. All members of A can be accessed now. X, Y and M1. Not only 3, you have 100 you can access. So all the members of superclass can be accessed from subclass object with the help of superclass variable. All the members of superclass can be accessed from subclass object with superclass reference variable. Same statement, ulta bulta I am telling you. Understood? Are you clear with this? Any questions? Any questions? Ulta is not possible. Fine. Next, one more we'll see. Supposingly B is not extending A. Now what happens? Now you only see. If I create A object, what are the members of A? X, Y, M1. If I create an object of B, what are the members? These are the members. Z, M2. These are the members. This is A object, this is B object. How can A refer to B, B refer to A? No, not possible only. So when they are different, it is not possible. Understood? When they are different, it is not at all possible. But when they are related, it is possible. Related when? When there is a relation. Understood? When you say A is equal to new B, is this correct now? If I say A is equal to B, what will happen now? I'll try to access from B what? X, Y, M1. Where is there? In B where you are having X, Y, M1? No. Similarly, if I say B is equal to A, what will I try to access? Z and M2. Where is Z and M2 in this object? So both are wrong here. A is equal to B is also wrong. B is equal to A is also wrong in this condition. But just if I add extends A, now story is different. Because when you create B object, it will have A object is similar. But B object what it will have? X, Y, M1. Now A is equal to B is in this condition. A is equal to B and B is equal to A. If you take in this condition, this is correct. This is wrong. You understood all the permutations and combinations? Under what condition is A is equal to new B valid? Understood? B is equal to new A is invalid. Means provided B is a subclass. Provided B is a subclass, B is equal to new A is error. Clear? Any questions here? I'll type this and show it to you. Very, very important. Check this and come. Tomorrow you'll be seeing dynamic polymorphism. Understood? Tomorrow the things will be little changed and you might get confused. Understood? better you work too much on the subject income. Too much. Understood? Clear with this? Shall I clear all this? Shall I clear? Any questions here? Any questions, sir? No questions? It looks simple now, and you might be thinking, what is the use of this, all that? Correct? No, I told you before in hand only. You will get doubts. What is the advantage of all this? I have already given you. There are 3 great advantages: decoupling, dynamic polymorphism, and what? Abstraction. Very high level of abstraction. So all that I have to explain you now. Again, all those points I have to explain you with what? Example only. Definitely, if I tell you concept, what will you tell? Sir, example you will tell. I am going to give you. Don't worry. Clear with that? So plenty of examples you are seeing to understand each and every concept now. See, this is a very powerful feature of Java. Practice a lot. You don't know how important this is. Your life, full life depends on this. I'm telling you. You are working in IT industry. This concept is so important. Understood? For your entire life in software industry, this example is very important. This is the base for many things. Class A. So do not neglect this. Do I ever stress so much? No, then understand. First I'll show you unrelated, then we'll make it related. So you know what I've written now, x, y, m1, but b is not related with a. Yes, sir? It's not related, it's not extending. So fine. Now see, a is equal to new a. You know how to work with a object. A dot x. Don't think I'm initializing, just think that I'm accessing the members. You know how to work with a object, and if you want you can print the values. See here, now don't think that I'm initializing and printing. Think that I'm accessing X with A. I've created superclass object and I'm using superclass variable to work with the object. Understood? I've created superclass object and I'm using superclass reference variable to work with that object. Clear? And I'm accessing X. Here also I'm accessing X, but it looks like initializing. Fine, no problem, but we are accessing. Here also I'm printing the value. But what do you understand again here? Accessing. Okay, and I'm accessing the method also. So variables I'm accessing twice, one to initialize, one to print. Method I'm accessing once, but I can access all the 3 members now. X, Y, M1, yes or no? Yes. So here what is the thing? Variable and object are of same type. Understood? The superclass object and superclass variable are of same type, all this is correct. You know how to work with A. This is, you don't have any questions here also. Okay, but the next thing what we have to learn is B. B is equal to new B. Yes, we have to learn this now. So now see, in this object also I have created subclass object. Again, don't think that I am initializing. You think that I am accessing. Okay, sorry, we are still not related now. B dot Z is equal to, I'll give a like 30. Anything you give, that's your wish. So I have created B object now, and I can print value of Z in B is plus B dot Z, and I can also print P dot M2 method. Any questions here? So we are working with B object, yes or no? Again think I am accessing Z twice, one to initialize, one to print the value, other one is I am calling the M2. All is perfect here, till now no issues. But if I try to say A is equal to B, who will give the error now? You are trying to give the reference value of B to A. Compiler only will report the error. This is not possible. You are trying to give some reference value to, means the, why will give the error? The type of value and variable are not matching. This topic I have explained to you too much in primitive. Always when you are assigning a value to a variable, what is most important? First, the type of value. So the reference value of type B cannot be assigned to A. This is error is reported during compilation time, incompatible type. Or if you want to comment all this and or directly try to say what? In one line only you try to do. A is equal to, check this out, A is equal to new B. This is also error. There I did after creating the object. Here I am trying to create the object and give it to A. Both are same. So either you do so this is also error. A is equal to B is error. This is also error. There I created object and did it. Here also same error. Understood? But one small change you can notice. Extends B, compiler will not report anything. Sorry. Extends A, compiler will not report any error. It is possible. Are you clear with this? A superclass reference variable can refer to what? Subclass object. Clear? Okay. But we'll state elaborately now again. I'll comment that. Now see, when I create B object, now see what I'll access. B dot X is valid. Correct now? B dot Y is equal to valid because it's a subclass object, it is having both the members. Superclass members plus subclass members. And I can print all the values also. I'll comment this for a time being. Are you clear with B object now? Just check how you are working with B now. Clear? So focus on B now. I'll comment A if you want. Okay, let it remain. A you leave. Focus on B now. Look at the bottom now. X in B is 10, X, Y in B is 20, Z in B is 30. Are you seeing it now? X, Y, Z in B is clear? So and it's executing both the methods. I think in here I have printed M1. Let's change it to M2. So it's printing M1 also, M2 also, using what? B. Are you clear? Now this will start. A is equal to B. Okay, before that, one more. We'll print the value of A. Check the value of A. Value of A is plus A. Now focus on this output now. Value of B is, I'll make it a small b, make this also a small a. So done. Let's see the output. See the address. A address is 3E25A5. B address is 1982, something like this. Are you clear? Okay. Now I'll say A is equal to B. Let's go with this formula now. It's sort of deriving, man. I'm trying to derive it today. And it's something like I'm deriving PTR by 100 today. What is the use of PTR by 100? Tomorrow I'll start seeing. You know, in mathematics you derive formula, no. When you're deriving formula, you'll not understand what it is. Okay, when you start using, you'll start understanding what is the advantage of that. Clear? Think that we are deriving what? A is equal to new B now. So now see, A is equal to B. Highly valid. It's compiling. Earlier it was giving error. Now you see the value of A. Value of A. Here I'll change it to something like star star star. Just for reference purpose you can do all this. Done? So the value of A with star we'll see. Earlier it was plus plus of A is what? 3E25. But with A star 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 is what? See this value. What value? B value and which one? A value are same now. Check. So it clearly shows B value and A value as same now. Both are referring to the same object. So A is referring, the other one is dereferenced. Which object? This object is dereferenced because A has started referring to B object now. Don't bother about dereferencing now. Just let's continue now. So with A, now let me access the members. After doing that, now I'll access the members. What members I can access? So let's print the value of X and Y now. Let's see what will be the output. So you can see it's printing 10 and 20. Earlier it was printing 1 and 2. Earlier what it was printing? 1, 2. The same it is printing as what now? 10 and 20 because it's referring to subclass object, different object. But let me try to access the other members. What? A dot Z. This is error. Z in A is what? Plus A dot Z. Error. Definitely error. See there. Z is present in the object, but I can't access it with A. With A I can't access. If you want to work with Z, it is possible, but with B. You try to print B dot Z, definitely it will work. What is the problem? Yes or no? Definitely it will print. What is the error? So I can work with that value, but with B variable. So it's like both the variables are referring to the same object now. This is X, Y. See, earlier it was like this. X, Y, M1. A was referring to this object. 1, 2. We created the B object. X is 10, Y is 20, M1 is there. You are having Z, which is 30, and you got M2. Now A is referring to this particular, this is dereferenced, leave. But I can access only superclass members. If you want to work with Z, you can use B dot Z. Clear? So superclass variable can refer. Are you clear with this now? Even I cannot access what? I cannot access the method also. A dot M2 also I cannot access. M1 I am accessing, but I cannot access M2 because it's in. So this A dot Z and A dot M2 both are errors now. Means I can't access subclass members. A dot Y, sorry, A dot Z, yeah, the last line, this line, these two lines now. A dot Z also I cannot access, M2 also I cannot access now. Are you clear? Still compile. Both are errors. Cannot find symbol. Which one? A dot Z. Cannot find symbol. Which one? In class A, it is very telling, clearly telling, class A, variable Z is not there. In class A, method M2 is not there. Very clearly it is telling. Clear this? Okay. So this is done. More things to see. What is that? Ulta will see now. What? B is equal to A. It will not compile only. How will you give subclass? You are trying to give what? Superclass reference value to subclass reference variable now. A superclass reference variable cannot refer to. So once again, a subclass reference variable cannot refer to superclass object. A subclass reference variable cannot refer to superclass object. But ulta is correct. Superclass reference variable can refer to subclass object. That is correct. Why technically you only see no? If B refers to A, what will happen? It will try to access which member? Huh? members of B? No. All members of B should be accessible? No. But where are the members of B now? So since it is not satisfying the condition, they are not letting it happen, and this problem is detected at compile advantage. More problems are reported at compilation time, you will face less problems in runtime. Understood? Correct only. Are you clear with this? Now finally we will see what? I will comment all this. Comment that A is equal to new B is a highly valued formula. Yes or no? Let's see now. And I can initialize, but I can work with only what? X, Y, M1. Z is there, but I can't work with it. I can't work with it. It can never work because now B is not referring to this now. Earlier what was happening? There are two variables. One A to A object, B to B object. If I want to work with B members, I could have used what? B variable. But now I can never work with the subclass members. Yes or no? Why? Because superclass variable is referring to subclass object. There is no other variable referring to what? Subclass object. Now I cannot work with Z at all. Yes or no? But there is a way which I will teach you later. There is a way. I will be covering that later. But first see this introduction. A is equal to new B is correct. Are you clear this? You understood the derivation of this formula? Is this correct? Any questions you are having here? But A dot Z is error, it is present. Right now I can't work. A dot M2 also error. I cannot work. Both are errors. But it is present in the object. Compiler will not compile. Forget object creation. Object creation is far off. What members you can access from the object depends on what? Type of variable. Compiler will not allow you to compile only. Understood? So what members you can access from the object, that's what I was telling you all these days. Depends on the type of reference variable, and it is detected by compiler during compilation time. This was the statement I was telling you all these days. And that time you might be thinking, definitely it will be accessing variable and or object of same type. Yeah, there it was possible. But when the variable is of superclass type and object is of subclass type, then that statement becomes more intense. Understood? But I started that statement long back so that you will catch it up very fast now. Understood? What members can be accessed from the object depends on what now? Type of reference variable, superclass reference variable. Clear this? Do you have any questions? Practice this. Advantages, tomorrow you'll start seeing. Understood? And now, you can try working like this also today. What? Not only, which one? This, A and B. You can also work with what? See this statement. Box B is equal to new box is highly valid. We know that. And you can access only B members. B.W, B.H, B.volume. Volume you can access. Box B is equal to new box weight is also valid. Valid code. Or box B is equal to new shipment. 1 second. When I do box B is equal to 1 second, I'll write all the stories. You can check it out today. Box B is equal to new box 1, 2, 3. Assuming that these are the members, assuming that class box is there, members will be WHND, volume method, M1 method. Assuming that these are the members. Class box weight is there, int weight is there. I'm not writing the constructors. Understood? Int weight is there, M2 method is there, M2. A different method I am writing. For the purpose of what demo now? Superclass to subclass I am telling you. Understood? You can write anything inside M2 or something you write. Now, but box weight is extending what? Box. Class shipment extends box weight. I'm writing it in shortcut, write it fully. Here I'll have what? Int C M3 method. This is the condition now. In this condition, let's start seeing now. So with B I can access what? I can access whether you initialize or print, that is secondary now. But I can access what? B.W, B.H, B.D, B.M1. All are correct. Because variable and object are of same type. Superclass variable is referring to what? Superclass object. Small change now. box B is equal to new box weight 5, 6, 7, 8. Object of what is created? Box weight. But who is referring to that now? B, superclass variable. Now what happens? B dot W, B dot H, B dot D, B dot M1, B dot W, B dot M2. So all these are correct, but these two are wrong. What members you can access from the subclass object depends on the type of superclass variable. Next, box B to any level in the hierarchy, you can create the object. Box B is what? Referring to which one now? Shipment, valid, and see this B dot W, B dot H, these are the members you try to access. Once again, all the correct I'll put first. See, these are all present, but only 4 members I can access. B dot WH and D. Sorry, I made weight here again. Sorry, change it to M. Sorry, mass. Sorry about that. Yeah, B dot WH and D valid, B dot M1 valid. So I can access all the members of box. Now the subclass members, B dot M wrong, B dot M2 wrong, B dot C wrong, B dot M3 wrong. Mass M2, cost M3, all are wrong. Clear? Not only in this hierarchy, this is also valid. Shipment S is equal to new what? Sorry. Box weight BW is equal to new box weight, you know, but shipment is correct. Valid. But with BW, how many members I can access now? See here I created shipment object, but it was referred by B. With B, how many members I was able to access? 4. But now I created which object? Shipment. But I am referring to which one? BW. Now how many members I can access? 6. 4 from superclass, 2 from subclass. Means this is valid. BW.W, BW.H, BW.D, BW.M1, BW.M, BW.M2. But BW.C, BW.M3, these two are errors. So what members you can access from the object depends on the type of variable. Getting the point? All are valid. Try this today. Understood? Is the concept clear now? What members can be accessed from the object will always depend on the type of variable. What type of a variable you are using? Superclass variable, or its subclass, or its subclass, like that. Yeah, and errors will be reported at compilation time. Clear? Any questions? Advantages, usage, I will be showing you from tomorrow. Understood? Any questions? You can take more hierarchy. Check it out. Clear? No questions? Okay, that's it.